In this lesson, we're going to be looking at how we can use Logger Pro to analyze motion from a video recording. And there are a couple of ways that you can do this. First, you need to go to the Insert menu, and if you choose Video Capture, Logger Pro will automatically synchronize with the camera in your computer so that as you are recording, the recording goes directly into Logger Pro so that you don't have to import the movie. What we're going to do today, though, is go ahead and choose Movie to import a movie that we had taken earlier. And to do that, you just need to choose the video that you want to analyze, and you can see that now the video that we're wanting to use is automatically put here into Logger Pro. One of the things that you want to keep in mind as you're doing any sort of video analysis is that always within your video frame you need to have some sort of a meter scale so that we can set the distances that are actually being moved within the video. And to do this now, we just need to enable video analysis, and I'll choose the ruler, and I'll set this scale so that we know exactly how far 1 meter is within our frame of view. And you can see that this would be 1 meter. The next thing we'll do is set the starting point of our video because we don't want any excesses. And so I'll just keep scrolling this along until the crawler comes into our field of view, and then we'll start analyzing the video. Alright, so there it is, first coming into view. I'll now go here and set the origin, and I'm going to be focusing on that front hub of the crawler so that every time I make a mark, I'm going to try and center the crosshairs on the hub of the crawler so that we're as accurate as possible. Now all we have to do is start marking our points, and you can see that each time I click on this, it automatically advances 1 frame, and as we click and mark each of the frames, you can see that Logger Pro is automatically plotting those points for the X distance and the Y distance moved within our video frame. And normally we would do this for the complete motion, but we'll add just a few more points and that will be sufficient for what we're doing today. Alright, now all I have to do is click on the graph, and you can see that we do have our data along the x-axis plotted against time and the y distances that have been moved plotted against time. And since we're only looking at motion in one direction, in the x direction, we'll go over here and choose x so that now we have the x distance that has been moved, the distance it moved along the x-axis plotted against time. And if you remember, on a distance time graph, the slope of this is going to give us our speed. And you can see that it's a very straight line, so very constant speed. If we go under Analysis and Linear Fit, you can see that now automatically we see a straight line going through the origin. Our slope is approximately 0.42 meters per second, which would be the velocity or the speed of the crawler. Now, we can confirm this by going over here and choosing X velocity, because it has also been calculating the velocity as we go along. And at first, as you look at this, it looks like our data is all over the place. But look at our scale here. our scale is only going from 0.35 meters per second to 0.45 meters per second. So this is representing a complete change of 0.1 meters per second, which is very small. So let's scale this a little more appropriately. We'll move this up to 0. There. And then we'll move this down. Since we had a scale of 1 meter, let's move this down to 1 meter also. And if you look, that is, if we put our line of best fit in there, a very good line here, horizontal, meaning constant velocity. You can see our slope is very near to 0. So for our velocity time graph, this slope would represent the acceleration, which you can see that acceleration has a slope of 0.005 meters per second squared. That's pretty close to 0. 0 acceleration, meaning constant velocity. So here you can see we can look at the velocity time and the distance time, and both of these are confirming that our motion in this case was constant motion.